Hello and good afternoon. Today, me and my friends are going to present our assignment for business statistics.
Assalamualaikum and very good morning to everyone. I'm Nur Afika Amira binti Ottoman and my matric number is A21A2755. So today I would like to present about data description. Data is any number of relevant observations put together. Data interpretation means explaining what the data means. A data set is a group of information that is usually shown in a table. Each column is a different variable and each row is a different member dataset query. In statistics, a set of data usually comes from a statistical population of samples based on real observations, and each row corresponds to a part of the observation, which is the population. In this case, the data was divided into 6, which is liter per 100, kpl, cylinder, horsepower, weight, and brand of cars. But all types of cars are different by their own weight, horsepower, cylinders, kpl, and also liter per 100.
Hi, Assalamualaikum. My name is Raja Muhammad Amir Safwan bin Raja Ahmad Shah. My matric number is A21A3048. Now I want to present about the sampling data and record categorical data. Sampling is a process of selecting a number of individuals for a study in such a way that the individual represent the sample from the target population. A sample should have the same characteristic as the population it is representing. Three factors that influence sample representing are sampling procedure, sample size, and participation. Categorical data is a collection of information that is divided into groups. General characteristics of categorical data include categorized, qualitativeness analysis, graphical analysis, interval scale, numeric value, and nature. Our group has recorded liter per 100, kpl, cylinder, horsepower, weight, and brand into nominal to observe the data set of life insurance charge. The resulting data is referred to as categorical. Type of categorical data are nominal data and ordinal data. For the sample data, we refer from the lower two-digit matrix student name Muhammad Afiq Aizil bin Rosli, which is A21A2611.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aina binti Zamri and my number matrix is A21A2765, and I'm going to present about the numerical descriptive measurements, which is chapter 3 for set A. It has 3 parts, which is measure of central tendency and measures of position and also measures of variation. So the first is the measure of central tendency for the first variable, which is liter per 100 km. So the mean for liter per 100 is 6.32 km. Next is the median for liter per 100. The class median is 6.21 to 7.80, and the median for liter per 100 is 5.98 km. And the mode for liter per 100 is 7.23 km. The mean for kpl is 60.53 km. And next median for kpl, which is the class median, was 14.44 to 17.15. So the median for kpl is 16.08 km per liter. The mode for kpl is 14.43 km per liter. Next, the mean for horsepower, which is 1.36, and the median class is 1.30 to 1.50, and the median for horsepower is 1.140. So the mode for horsepower is 1.367, and the mean for weight group is 3.87 kg. Next is the median for the weight group, which is the class median is 3.590 to 3.849, and the median for weight is 4.29 kg. Next, the mode for weight group is 3.746 kg. Next is the measure of position. So the first variable is the liter per 100. So for the first quarter, the class interval is 5.23 to 6.20, and the class interval for the third quarter is 6.21 to 7.18. The value of the first quartile is 4.9436 and the value for the third quartile is 6.5651. For the interquartile range for liter per 100 kilometer is 1.62150. Next is the major position of KPL, which is the first quartile. The class interval is 11.72 to 14.43, and the class interval for the third quartile is 17.16 to 19.87. Value for the first quartile for position of KPL is 13.2126, and the value for the third quartile is 18.2325. The interquartile range for KPL is 5.0199. Next is the major position of horsepower. Class interval for the first quartile is 0.88 to 1.08, and the class interval for the third quartile is 1.51 to 1.71. The value of the first quartile is 0.5605, and for the third quartile is 1.0656. And the interquartile range of horsepower is 0.5051. The measures of weight. The class interval for the first quartile is 3.330 to 3.589, and the class interval for the third quartile is 4.110 to 4.369. So the value for the first quartile is 2.9250, and the third quartile is 3.7577. Interquartile range for the weight is 0.8027. The lastly is the measure of variation. So the first variable is for the liter per 100 kilometer. So for the sample variance for liter per 100 group is 1375.470316 kilometer. So for the standard variation for liter per 100 kilometer is 37.08733363, and the shapes of data distribution for liter per 100 group is skewed to the right. The next is the sample variance for KPL group, which is 1117.606074, and the standard deviation is 33.4306158.1, and the shapes of data distribution for KPL group is skewed to the right. Sample variance for horsepower is 1.7339999659, and the standard deviation is 1.316814208, and the shapes of data distribution for horsepower is bell-shaped. The sample variance for weight is we receive 40.96467,183 kg, and the standard deviation is 6.400364,976, and the shapes of data distribution for weight is skewed to the left.
Hello and good afternoon. My name is Anandan. Today I am going to present my part about graphical representation. Graphical representation of data is an attractive method of showcasing numerical data that help in analyzing and representing quantitative data visually. A graph is a kind of a chart where data are plotted as variables across the coordinate. This is the table for our first variable, brand. The table above shows brand of cars. There are 7 brands of cars, that are BMW, Audi, Ford, Honda, Citroen and Opel. The total frequency for car brands is 150. From the histogram, we can see that the graph is labeled the x-axis with brand and the y-axis is frequency. The graph above shows frequency for 7 car brands. Frequency for BMW is the highest, that is 44, and the frequency for the Citroen is the lowest, 2. Honda is the second highest frequency, 37, follows by Ford is the third highest, 36. Moreover, frequency for Mercedes is 15 and Audi is 12. Opel is the second lowest frequency, 4. And this is the table for second variable for cylinder. The table above shows type of number cylinders. There are 4 types of number cylinders, that are 4, 5, 6 and 8. From the pie chart, we can see that there are 4 types of total engine cylinders for each vehicle, namely 4, 5, 6 and 8. The graph above shows the percentage for types of number cylinders. The highest type of number cylinder is 8, 96, with a percentage of 64%. The second highest is type of number 6, 48 with a percentage of 32%. Besides that, number of 4 is 5 with a percentage of 3%. The lowest types of number cylinder is 5, 1 with a percentage of 1%. That's only from me from this part. Thank you so much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq Aizal bin Rosli. My matrix number A21A2611. Today I will present about 5.0 statistical analysis using software. SPSS stands for Statistical Package for the Social Science. SPSS provides data analysis for descriptive statistics, numerical outcome prediction, and group identification. 5.1 Numerical Descriptive Measure. The mean using SPSS for the liter per 100 group is 6.3270, while the mean by using manually calculate is 6.32, which is the same. The answer for median by using the SPSS is 6.25 and using manually is 5.98 with a difference of 0.27. Next, the answer of mode that we get by using the SPSS is 7.69 and using manually is 7.23 with a difference of 0.46. The standard deviation in using SPSS is 1.318 while using manually is 37.087. Both has a difference between 35.769 values. Variance for SPSS is 1.738 while for manually is 1.738 with the same values. For range, minimum and maximum values calculated by using SPSS are 11.11 and 3.26 respectively, and those are the same as the calculate manually. Lastly, the answer of percentile for quartile 1 by using the SPSS is 5.3981 and for quartile 3 is 7.1429, whereas using manually calculate is 4.9436 for quartile 1 and 6.5651 for quartile 3. 5.2 Hypothesis testing. The hypothesis is a proposition, statement, or assumption based on some previous observation about the value of a population parameter for testing purpose. T-test for the first pair. Decision rule. Reject HO if T bigger than TA/2. Critical region T 0.025 equal 1.96. Decision. Since T bigger than TA/2 in bracket 44.19 bigger than 1.96, reject HO, and we can conclude that the two sample means are not equal or there is significant difference between the two sample means. T-test for the second pair. Decision rule. Reject HO if T bigger than TA/2. Critical region T 0.025 equal 1.96. Decision. Since T bigger than TA/2 in bracket 13.05 bigger than 1.96, reject HO, and we can conclude that the two samples means are not equal or there is significant difference between the two samples means. ANOVA for all variables. The factor that has been chosen is horsepower. The p-value from the ANOVA table is less than 0.001, which means that at least one of the three variables, that is liter per 100, kpl, weight, horsepower, cylinder, and brand. 5.3 Correlation Analysis. Correlation analysis is a statistical technique used to determine how two variables are related. In statistics, the word correlation refers to the relationship between two variables. A relationship exists when charges in one variable are accompanied by consistent and predictable change in the other variables. 5.4 Confidence interval. The mean for liter per 100 group is 6.3270. The upper bound is 6.5397 and the lower bound is 6.1143. The difference between upper and lower is 0.4254. The mean for KPL group is 16.537. The upper bound is 17.139 and the lower bound is 15.537. The difference between upper and lower is 1.602. The mean for horsepower is 1.3673. The upper bound is 1.4282 and the lower bound is 1.3065. The difference between upper and lower is 0.1217. The mean for weight is 3.86090. The upper bound is 3.94455 and the lower bound is 3.77725. The difference between upper and lower is 0.1673. 5.5 Prediction modeling. Multiple linear regression is the most common form of regression analysis. It allows us to use several variables at once to explain the variation in a continuous dependent variable. It also allows us to isolate the unique effect of the variable on the constant dependent variable while considering that other variables are affecting it too. Thus, every value of independent variables is potentially related to the dependent variables. In the scatter plot matrix, graph 1 plots KPL against weight against horsepower. Generally, the older the person, the higher the value of life insurance charge. There is a strong positive correlation between variables. Graph 2 plots liter per 100 against KPL against weight. There is a strong positive correlation between higher life insurance charge. Graph 3 plots liter per 100 against weight against horsepower. There is a strong positive correlation between these variables. Correlation. The R value between liter per 100 and KPL is negative 0.949. Thus, liter per 100 are associated with KPL. The R value between horsepower and weight is 0.718. Horsepower are associated with weight. Model summary. The R square value is 0.912, which means 91.2% of the variation in liter per 100 can be explained by KPL, horsepower and weight. The adjusted R square is 91%. ANOVA. The p-value from the ANOVA table is 0.00, which is less than 0.001. Therefore, at least one of the three variables, which are KPL, horsepower and weight, can be used to model liter per 100. Coefficients. The equation is liter per 100 equal 9.819 minus 0.296, that is KPL, plus 0.146 horsepower plus 0.313 weight. Based on the standardized coefficients beta, the effect of KPL is minus 0.838 is almost 0.3 times that of horsepower 0.042 and weight 0.095. The p-value for only KPL and weight are less than 0.05.
My name is Angel Rina Jerry. My matrix number is A21A3223. Conclusion. All of the concepts and methods of calculation that we have to accomplish in business statistics are extremely clear to us as students. Secondly, this statistical thinking necessitates rigorous research designed by all of us students in order to obtain tangible data in order to respond to the question of focus science, in-depth analysis of data structures, as well as conclusion of the study. Thirdly, random sampling is necessary for generalizing the result of our survey to the generic public, as well as randomized assignments is crucial for generating ideas about the report's causes and effects. This assignment can teach us a wide range of skills, such as how to use Microsoft Excel program and how to perform various types of calculation, which will be extremely useful in our jobs and which we will be able to perform with confidence in the future. We should presume that our goal has been met after completing this assignment. This task requires us to determine the dataset and variable types. Every secondary dataset, including frequency distribution, relative frequency distribution, and cumulative frequency distribution, should be represented by proper schedule. Lastly, both random potential models aid in determining how much further we may expect random fluctuations in our data, allowing us to evaluate our research results on their own and estimate the margin of error from the research we are conducting. Thank you.
Subject.